Welcome, you've come back. You've come to watch more maths. What are we going to do today? We are going to solve a horrible nonlinear differential equation of doom. We're going to have a little think about what we can do to solve it. Now, this does look like a substitution. We've just got to choose. We've been given no clues as to what the substitution is, but we figure we're going to need one. So it's dy dx plus square root of y plus 1 equals y plus 1. Y is greater than minus 1. Y of 0 is at 3. Now, why do we need y is bigger than minus 1? Because of the square root. Now, one option that we might look at, because we've got this repetition of y plus 1, we could have a go at u is equal to y plus 1, which will give me du by dx is dy dx, so that's fine, plus square root u is equal to u. And that still does not bring me a whole lot of joy, I won't lie to you. That does not bring me a whole lot of joy. Because I've still got a root u here. That is not fun at all. I can't do integration. I can't do an integrating factor because I need just a u here. Could swap them over, I suppose. But then I want a function of x on this side, and I've got it's just terrible. It's just a terrible idea. Okay, nice try, sucker. Let's try something else. Well, how about, we didn't like that square root, did we? So let's get rid of it by going u squared is equal to y plus 1. Let's try that. So let's differentiate. 2u du is dy. If you do implicit differentiation, you can get 2u du dy, or you can differentiate with respect to u on both sides. Right? Either way, you will end up with this relationship. So let's see what we get. We end up with 2u du dx. Let's put the dx's in. 2u du dx plus square root of y plus 1, so that's going to be u, is equal to u squared. Ooh! Because what can I do now? I can divide everything by 2u. And I end up with du by dx plus a half equals u over 2. Now, if we just rearrange that just a little bit, du dx minus a half u is minus a half. Now, this is set up beautifully for an integrating factor. So my integrating factor is e to the integral of minus a half dx, which is e to the minus a half t. So what does my whole thing become? Let's bring that back over there. Let's tighten that up a little bit. There we go. So what does my differential equation become? It becomes e to the minus a half t du dx minus a half e to the minus half t u is minus a half e to the minus a half t. And I can just integrate all of that. So I end up with e to the minus a half t u. The whole point was to get a product rule on that side. Integrate the right-hand side, and I'll get e to the minus a half t plus c. All right, now it's probably a good time to find what plus c is. So let's plug that in. Now, u of 0 is square root of y of 0 plus 1 is 2. So let's plug that in. Why am I doing this with t's? Right. Where did the t's come from? Someone's been doing too much parametric. This is your brain on parametric equations. Right, let's try that again. Plug in x is 0, I get 1 times 2 is 1 plus c. c is 1. Times it through by e to the half x, I end up with u is 1 plus e to the half x. So I need to square that. That's 1 plus 2 e to the half x plus e to the x, and then take away 1 to get y, That's kind of cool. kind of cool. I like that. I think we could probably do something with that as well, but I don't know. You'll probably do something with that, but I'm not gonna. Don't know. Could take out an e to the half x and end up with e to the half x plus 2. I don't know if that's useful, 21. Don't know. Right, cool. That's pretty sweet. Oh, you could then, oh. No, you can't. That's fine. Ignore me. Ignore me. Okay, so a cute little substitution. We end up with something that is relatively straightforward to do. Lovely little substitution to spot. And again, with substitutions, you can just play around with it until you find one that does what you want it to do. You don't have to have a clear plan straight away. Just play around with it a little bit, right? It's the thing. It's maths, right? We can have a bit of fun for a very narrow sort of subtopic of fun. Either way, please don't forget to like, subscribe, hit the notification so you know when more of this is coming out, so we can discuss the pitfalls, the funs, the highs, the lows of further mathematics together here at Nick Does Maths. I expect to see you next time, so I will see you then. Bye-bye.